actual OID resolver says, well, I see 2543, but that's not a common name. And indeed, it is the same with Netscape, which also sees 2543, but does not see it as a common name. Internet Explorer, common name. You can actually have a certificate with 25403, and it will resolve it back to common name. Semantic integer overflows. These are fun. You can actually, and this is kind of neat, integer overflows are one of the most common bugs in software today. I have not actually met a non-security developer who has actually realized that numbers wrap if you multiply them too large. They don't wrap in, human space, but if you have a 64-bit range and you say 2 to the 64, that's also 0. The number's too big to fit in the space. It wraps. Now, if you're saying this is usually used to exploit memory allocation, you say, hey, I want you to allocate some huge number of items, that wraps to 0, and now you can go ahead and the system thinks it's allocated a huge number, but it's actually not, and you get to write unallocated space. It turns out this can work semantically. What if you have 2, 5, 4, 2 to the 64 plus 3? That's what it looks like in hex. You have the 82 and a bunch of 80s. It turns out OpenSSL does not care because OpenSSL has what's called a big num library. And it actually expands out 2 to the 64 all the way. It is not tricked whatsoever. Firefox is totally kind of tricked. It sees it as 2543, but its OID resolver sees nothing wrong with it. Sees something wrong. This is not the byte sequence that I was looking for. And it actually has it as 2543, but does not see it as CN. Internet Explorer sees it as a CN. Awesome. So, that being said, most CAs are going to extract the common name and throw away the rest. Is there anything malicious that we could get into the common name itself? Something that could get in there, that has to be in there, has to be seen, but you can't throw it out. Well, let's actually look at what is in the value of a common name. You have an object identifier, 2543, and you have a printable string, www.docsparrow.com. Type 13, length 15, and there's the actual ASCII for www.docsparrow.com. There's some magic that we can do in that printable string field. First off, there are 13 different types of strings in ASN1 because they hate me. And the easy thing you can do is use some of the multi-byte encodings. It turns out this creates a trivial read AV in OpenSSL PKCS10 parser. So what they were doing is they were saying, wait, let's keep reading until we're at the end of this string. And then they would skip either 2 bytes or 4 bytes until they got to the end of the string, the exact value of the end of the string. If you gave it a string that was not at the actual offset, either 2 bytes or 4 bytes, say you gave it a 7-byte string, it would miss the terminator and jump right over it. This was very exciting. I was, oh, holy crap, I wasn't even trying to exploit this. I'm already getting a segfault. Sweet. Not exploitable. Why? Because OpenSSL does not actually write any memory after that overflow. It just keeps printing out some dynamically growing buffer and eventually hits a guard page and blows up in your face. But it blows up securely. So at best, it's a DOS. Props to those guys. They wrote some secure code. But there is something fun we can get in there. There are 2 ways of ending a string like www.docsparrow.com. One way is with an explicit length field. So ASN1 gives you a length field that says, for the love of God, the next 15 bytes are this string, deal with it. Or you can have a null terminator. This is what is known as a C string. If you put a null terminator, an OXOO, in the middle of a common name, OpenSSL will see, say, www.defcon.org. No, literally, it will turn into /x00 www.oxoo.com. Any certificate authority will see this as, oh, this name is part of oxoo.com. I'll go find out who owns oxoo.com, which happens to be me. But every browser sees that as www.defcon.org. the actual name validated, stops at the null terminator. Shit. So I do want to be open with someone else who found this. Moxie Marlinspike and I actually went to the same conference within an hour of each other and unveiled this attack. We have it mostly, we're getting it killed. Firefox 3.5 already blocks the null terminator attack. Internet Explorer and others will be blocking it at some point. And we have as many certificate authorities as possible no longer allowing this. No, I can't tell you which certificate authority screwed up and gave me the null cert. Jeff Moss knows and Alex Soderov knows, so I promise you can go ahead and poke them, but it has been validated. So, I'm pretty worried about this bug. Lots of people have fixed it. Anyway, I've got a couple minutes. I'll talk about what I'm actually thinking we need to do. Do I think the certificate authorities are useless? I'm sure a lot of you don't like VeriSign. I disagree with you. VeriSign has an important service that they can provide. It's not just hosting COM. There is a really hard and lame problem that we would like to define away, but we can't. And it's, you know, www.bank-of-america.com looks enough like Bank of America for your mom. So, I mean, what are you going to do? Like, there's all these things that are called semantic collisions. They look similar enough to a real brand that you really trust, that you really want to give your credentials to, that screw all these crazy ASN1 length field attacks. Just go ahead and throw a couple dashes in until you get a name that isn't actually already taken. This is a necessary consequence of having what is known as a open namespace. Anybody can put a name in DNS. This is what a necessary consequence of the fact that DNS is delegated. I will always be able to create www.bankofamerica.com.doxpera.com. That is my power. That is my ability. We need a way that I can't get a SSL certificate for that. And that can't be done with normal certificates, but it can be done with this new crazy thing called extended validation. Extended validation involves actual lawyers on the actual ground in the actual language that's being spoken, and they have awareness of the brands at play. This cannot be done with neat, crazy technology. This has to be done with expensive people. Now, is extended validation perfect and the answer to all the threats in the world? No, no, no. Look, if you actually have a certificate for www.bankofamerica.com, extended validation does not stop you. It was never designed to stop you from messing with the real green bar experience, www.bankofamerica.com. The reason for this was very simple. The average website is composed of something like 10 different servers, from analytics to image servers to all sorts of crap. If you needed to go ahead and update the SSL certs with all of these things, with crazy expensive lawyers, no site could be defended by the green bar. So the browser developers said, you know what? That's not a problem we're trying to solve. All we're trying to solve is let's make it so bank-of-America doesn't work. But don't worry, the certificate authority marketers got a little bit ahead of the game and kind of said a little too much. So there were some attacks by Zussman and Soderov that just completely demonstrate that that barrier doesn't exist. So